Hello there, welcome to another video of software engineering. In this, we are going to see about class-based diagram. Right? In this, we are going to see something about class-based modeling. It's part of a modeling where we are going to see something about class-based modeling. Now, this is all handwritten, and I am going to explain you the class-based modeling. Before I tell you what is a class is basic building block of a model which have got all the information about anything, about a real thing, correct? Now it is represented in a rectangular box as you have seen it, and this is my name which is given a capital letter. First letter should be a capital, and then we have got the name of the class, which I told you this is the name of the class, and these are its attributes, means account number, balance, and these are the attributes we can able to see more. And these are its function. We have got deposit, withdraw, add loan. So these are that. So class is of three things which are nothing but name, and then and what are its attributes, or we can call it as properties, and these are its function. What are the functions? And name should be first letter should be a capital letter, and it represented a real things, information about it. Whereas in DBMS it just name and its attributes, whereas here it has got name, attributes, as well as functions. What are its functions? What type of function it's going to happen it? So I just told you the name, correct, and these are the attributes. If it is system ID verification, all these are, and these are its functions. These are its operation, or we can call it as functions. This is nothing but a basic building block of class. Now there are about we have got properties, correct? These operations can be displayed in different way. There are plus, minus, and some others. We are going to see it, correct? Here, first, plus means public. It can be seen by anyone and it can be used by any class. So if I class plus program, comma, this becomes public and it can be used by any class. Or here, if I ask correct, here I put plus display. It is a public which can be used by anybody. And then we have got minus, which is nothing but private. It cannot be accessed outside of the class. It cannot be accessed by the child. So if I write this one, reset or query, 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 and we write minus sign in before that one, then it cannot be used by other classes other than system classes, and it cannot be used by child of system classes. Do remember, it's a private class. So here if I wrote add loan to minus, then it becomes a different thing. This becomes a private property of that class, correct? Then we have got hashtag protected. It's a private, but it is more functionable. It can be used by child class also. What do you mean by that one? Like if I have this one, modi 5, so it's protected, but it can be used by its child or subclasses. Whereas this, if I wrote it, it cannot be used by subclasses, it cannot be used by child, and this becomes a protected. If I write minus, it cannot be used by subclasses and everything. If I write this hashtag, then I can be used by its children. Next part is this one, package. This is symbol represented package. Now the whole package is something like that, program. Means its whole program. Means if I take a system, if I take a bank one, I've got many classes that it's a loan account, it's a customer, everything. The whole software engineering project. In that, we call it as package, and this class or this program can be used anywhere in that package. Means if it is a hospital package and this program is of that package, then I can use anywhere in the package irrespective of the class or something like that. This we call it as package. So there are four properties. Do remember it. We have got plus, public, This is called minus, and private, this is got hashtag, which is private but it can be used by child, and this is called package, which can be used by all over the that packages. So there's four properties of operation, and what I mentioned here, this one public and everything. Now let's move on to others. Then we have got a relationship concept. Relationship is concept is denoted by a single line. Relationship concept is denoted by a single line with two classes with association. There are two types. One is aggregation and other one is composition. Correct? Aggregation is denoted by this symbol as a. Correct? Aggregation. Let me check the pen color. Yes, it is denoted by this symbol. Okay, has a account number. Account number. What is the balance? It is a deposit, withdraw, addition. This is public properties. Published program. Account number has a branch where it's in a branch. What is branch code? Add account, remove account, all this operation are, this is called aggregated, which is a part of it. Account, branch has an account, branch has an account, car has a steering, car has a what you call four tires, that becomes aggregated part of it. Now this is, look, account, branch. Now what do you mean by composite? Composition. What do you mean by composition? Composition, let's take example. It is represented with this one, correct? This whole line with dotted line. This represented with a dotted line. Composited. Account number has a branch, but where it is? In bank. Where is it? Bank. So bank location, and so and so operations are there. Remove branch. And if I remove this aggregate, if branch goes, will the account will go? No. It will come. It will be transferred to somewhere else. So it will come to the main branch. Let's take example. I have an example which is there. BOB is merged with Indian Bank. It doesn't mean that all the branches are merged with BOB. But what about account number is there? But the branches has been removed. So aggregate can be removed, but composition cannot be removed. Aggregate can be removed, that composition cannot be removed. This account can be shifted. Yes, it can be shifted. If you remove that aggregate, no impact. If you remove the aggregate, no import. If bank goes, the branches will not be there. If bank goes, the branches will not be there. So if there is no bank, let's take example, there was a problem with Yes Bank. Nobody can able to deposit. If bank goes there, but if any branch of Yes Bank which is there in Hyderabad goes, there is no issue. The bank account will be transferred to somewhere else. So this is the major property of your aggregate, and this is the property of composition. Hope you got the point clear. Right? Next other point is generalization, which is represented with the help of this one. And generalization, we have got account, all these details, and this is its account. What type of account? It's a loan account. What type of account? It's a saving account. So these are its child one. Generalization, anything, and any modification we can able to do in child, no issue. And if you modify, there is no issues in this one. Account, unknown can be there. Child classes, these are, now we got the concept of inheritance. This is your parent class, this is your child class. You can update your account number or loan number. You can already pay everything, all this thing. Minimum balance, opening date, add customer. This is what? Private, remove customer, correct? These are properties of your generalization. So remember the concept of aggregates, remember the concept of composition, remember the concept of generalization, remember the properties of your class. This is the concept of class diagram, correct? This, and then we have got cardinality ratios. That is concept of multiplicity. What is that? It is represented with 0, 1 and many. That is participation. 0 to 1, how many? 1 to many, that is 1 to many, many to many, many to 1. This is cardinality ratio. Now we have got, say, a customer can have, one customer can have an loan and loan account. That is many. 0 to many is represented with 0 to star. This is represented with many. And one customer can have only one saving account. One customer can have, you cannot have two saving account, you cannot have two current account. So that is nothing but your concept of multiplicity. That is nothing but your concept of cardinality, 0 to 1, many to 1. These are the ratios. And concept of realization. What is the concept of realization? We have got two. One is interface, other one is verification or dependency. So we have got two concepts in this one, realization. One is interface, other one is dependency. Yeah, account number. So all your bank transactions or your bank packages will be able to see through internet, will be able to see through internet, will be able to see through app. All your airline booking system will be able to see through easy makemytrip.com. That becomes an interface. That becomes an interface. That is called as interface, and it is represented with a dotted line and this one. So if there is an account number and everything, I did not draw all the packages here. I just told about this, sorry, about this class, and it is interfaced with the banking system. And let's take an example. I have opened an account. I have opened all the accounts, I've given all other card, biometric, and everything. But it has to get verified. Once it get verified, it will be done. You have submitted all your details to someone else. It has to verify, then you will get it. You have submitted all your documents to visa consultant or somewhere to the visa. It has to get verified, and you have to get visa. This is account. All these are verified. All this, once it is verified, when it is pressed S, your account is created. This is represented with dotted line and this mark. This is called dependency. Correct. Account number is dependency on verification, and interface is something like that where you're going to see with the outside world. And this is a simple diagram of a flow. Correct. I hope I have already clear. There is floor plan, and these are its properties, and this is wall and is a part of it. Place within this one. This is generalization. Correct. I hope I have cleared the concept of class diagram. Thank you very much. Class modeling.